Next theorem. The radical axis of any two circles whose common tangent is not perpendicular to the line joining the centers of the given two circles bisects the line joining the points of contacts of the common tangent to the circles. Let x square plus y square plus 2gx plus 2fy plus c equal to 0, equation number 1. Second circle, x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. Let c1 c2 be the center of 1 and 2 respectively. So c1 c2. Let the common tangent t1 of the circle 1 and 2 intersects the circle 1 and 2 at t and t1 respectively. Right, t1 common tangent, right, intersect first circle at t and second circle at t1. Join c1 and c2. Join the line joining the center. Given the common tangent t1 is not perpendicular to the line c1 c2 joining the centers of 1 and 2, right? We know that the radical axis of 1 and 2 is perpendicular to the line c1 c2, right, joining the centers of 1 and 2. So this is the radical axis. Clearly the common tangent t1 and the radical axis intersects at a point, right? So let p x1 y1 be the point of intersection of the common tangent t1 and the radical axis of 1 and 2, right? Since p x1 y1 is on the radical axis of 1 and 2, by definition of radical axis, power of the point p x1 y1 with respect to 1, which is equal to power of the point p x1 y1 with respect to 2, right? Not 1, again I put 1, so that is typo error. Instead of 1 you change it to 2, right? Second circle, power of the first circle which is equal to power of the second circle for the point p x1 y1, right? That is the definition. So power of the point x1 y1 with respect to first circle is x1 square plus y1 square. Replace x by x1 and y by y1 in equation number 1, right? 2g x1 plus 2f y1 plus c equal to 0. Similarly, power of p x1 y1 with respect to the second circle. Replace x by x1, y by y1 in circle 2. x1 square plus y1 square plus 2g1 x1 plus 2f1 y1 plus c1. That is equation number 3. The length of the tangent pt from the point p x1 y1 to first circle is given by, we know the formula, pt is equal to root of x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. Therefore pt square is equal to, remove the square root, so you will get x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. That is equation number 4. Now the length of tangent pt1 from the point p x1 y1 to the circle 2, that is pt1 equal to root of x1 square plus y1 square plus 2g1 x1 plus 2f1 y1 plus c1. So squaring both sides, so you will get pt1 square is equal to x1 square plus y1 square plus 2g1 x1 plus 2f1 y1 plus c1. That is equation number 5. From 3, 4 and 5, pt square is equal to pt1 square. This implies pt is equal to pt1. This implies p is the midpoint of t1 and t2, right? Because the length pt which is equal to length pt1, then p is the center point of tt1. Exactly, right? This implies radical axis of any two circles bisects the line joining the points of contact of the common tangent to the circle. Thanks.